If you were about to board a flight and learned there was an 18% chance the plane would crash, you would likely never step onto that aircraft. Most people consider those odds an unacceptable level of risk. Current scientific models suggest that same 18% probability exists for humanity today. We face nearly a 1 in 5 chance of pushing global temperatures past 4.5 degrees Celsius by the end of the century, a threshold that leads towards systemic societal collapse. This process begins with a physiological failure measured by the wet bulb temperature. This reading uses a thermometer wrapped in a water-saturated cloth to determine if the environment is still capable of cooling an object through evaporation. Modern civilization relies on a stable range of biological tolerances. When the planet warms beyond those limits, the collapse begins with the quiet failure of the human body's ability to keep itself cool. Human survival in the heat depends almost entirely on the evaporation of sweat. In dry conditions, moisture leaves the skin and carries excess heat away. But as humidity rises, the air becomes saturated. Eventually, it can no longer absorb the moisture we produce to stay alive. Researchers at Penn State mapped this limit by placing subjects in environmental chambers to find exactly when the body loses control. This chart shows the wet bulb temperature on the x-axis and the human core temperature on the y-axis. The data shows that at a wet bulb temperature of 31 degrees Celsius, sweat stops evaporating. At this point, the line spikes. Your core temperature begins to rise uncontrollably because your primary cooling mechanism has been neutralized by the environment. This starts a lethal countdown. Once the core temperature reaches 40 degrees, the body enters heat stroke. Without immediate intervention, organ failure and death occur in as little as 3 to 5 hours. Climate projections show these 31-degree events expanding to cover a third of Earth's land area by the time we reach 2 degrees of warming. This puts populous regions like the U.S. Gulf Coast, most of India, and eastern China directly in the path of unlivable conditions. When the atmosphere crosses this biological threshold, shade and hydration are no longer enough. Survival becomes a matter of engineering, requiring constant access to artificial cooling. Because our bodies can no longer regulate themselves, air conditioning becomes a mandatory life support system. It is the only tool we have to maintain a survivable environment in a 31-degree world. However, air conditioning creates a dangerous feedback loop. These units do not eliminate heat. They simply move it from inside a room to the street outside, while consuming massive amounts of energy. This process currently accounts for 3% of global greenhouse gas emissions, a number expected to triple by 2050. This creates a systemic vulnerability. During a severe wet bulb event, an entire population will run their AC units at maximum capacity simultaneously. This synchronized demand can easily overload local power grids, causing a total blackout at the exact moment cooling is most needed. We saw this infrastructure failure play out in 2015, when an extreme humid heat wave hit Karachi, Pakistan. Temperatures reached 45 degrees Celsius with oppressive humidity, pushing the city past the limits of human compensability. When the power grid failed under the strain, millions lost their only defense. Over 1,200 people died in just 10 days, illustrating how quickly a technical failure becomes a mass casualty event. Our primary survival strategy depends on a grid that is biologically certain to be pushed to its breaking point. These localized infrastructure failures eventually begin to erode the broader economy. As extreme weather events become frequent and predictable, the mathematical models that underpin modern capitalism start to fail. This erosion starts with insurance. When disasters like floods or hurricanes happen too often, insurers can no longer calculate a profitable rate and simply stop offering coverage in those regions. The consequences are financial. Without insurance, you cannot get a mortgage. Without mortgages, property values in places like fire-prone California or the humid Gulf Coast collapse, wiping out the wealth of millions and the tax base of entire cities. Scientists describe this as derailment risk. It is like a ship's crew trying to navigate through a worsening storm. To stay on course, they need to focus on steering. But if the hull is leaking, they are forced to spend all their energy bailing water instead. This bailing process consumes all available political and economic bandwidth. Governments become so overwhelmed by constant emergency responses, managing grid collapses and economic panics, that they can no longer coordinate the large-scale projects needed to stop climate change. The ultimate tragedy of derailment is that the disasters themselves destroy the very political and economic tools we need to implement global solutions. By the 2030s, a derailed society becomes highly susceptible to wildcard events. Imagine a world already economically strained, facing the collapse of the North Atlantic subpolar gyre, a key part of the ocean circulation that regulates global heat. This collapse would trigger immediate financial panic across the Euro-Atlantic area and disrupt major food-growing regions. In a world with diminished trust and bailing water politics, the ability to manage a sudden global food shortage disappears. If the full Atlantic circulation then fails, it would disrupt the monsoons over India and Pakistan. These two nuclear-armed neighbors already share a drying water resource. A total monsoon failure would turn a resource scarcity into an existential threat. History shows that when survival is at stake, regional tensions often escalate into conflict. In this scenario, a war over water could trigger a nuclear exchange. The resulting soot would block the sun, causing a nuclear winter and global crop failures that could kill billions. This is how the end of the world plausibly scales. A localized failure of human sweat leads to a grid collapse, which triggers economic derailment, ultimately leaving a fragile world unable to prevent a resource war from becoming a global nuclear catastrophe. In high-stakes fields like medicine or nuclear engineering, modeling the worst-case scenario is a basic requirement of risk management. Understanding exactly what can go wrong is the first step toward ensuring it never happens. During the Cold War, the study of nuclear winter was the very thing that motivated global powers to prioritize deterrence. Once the world understood that a nuclear war meant game over for everyone, avoiding it became the highest priority. We can apply that same logic to the climate endgame. Transitioning to clean, renewable energy solves the air conditioning paradox at its source. It allows us to protect vulnerable populations without overloading the grid or fueling the base problem of global warming. Clearly visualizing the end of the world is our most effective strategy for avoiding it. By understanding the chain of events that leads to derailment, we can act to break the first link. Subscribe to join us as we explore the solution.